Good day, viewers. In our class today, we are going to consider finding an estimator, single parameters using maximum likelihood method. If you have K1, K2 up to Kn as a random sample of size n from a discrete probability density function as this, where theta is unknown parameter. So the likelihood function L theta is the product of the PDF evaluated at the n ki's. So this means that find the likelihood function, we are going to evaluate the product to n of I is equal to 1 of our PDF function given as this. And if our samples is from a continuous function, we are going to have our likelihood function as the product evaluated to n from I is equal to 1 of the function fy y theta. So, to find the value of the parameter, of the estimating parameter that maximizes the likelihood is often an exercise of differentiation, and then we solve the equation theta of likelihood function is equal to 0. Then from there we'll be able to find our estimator, as we are going to see in the following examples. In this example, this is what we have. We have a gamma function, f of y as 1 over theta square, y exponential of minus y over theta, and 5 samples were collected. We are to find the likelihood estimate for theta. So this is our function, and by definition, likelihood of theta is defined as the product to n of I is equal to 1 of the function evaluated at different points. So we are going to find the product of this function evaluated at different points. This product to n of I is equal to 1 of theta to the power of minus 2, we can write this like this. So y exponential of minus y over theta. At first point, we are going to have theta to the power of minus 2, then y1 exponential of minus y1 over theta. At second point, we have theta to the power of minus 2, then y2 exponential of minus y2 over theta. At third point, theta to the power of minus 2, y3 exponential of minus y3 over theta. It goes on up to the last value. So simplifying this, we have this factor here, we have it here, we have it here. We are going to employ our knowledge in common logarithms or indices. They have the same base multiplying by each other. That means you have to add the powers. So in doing so, we'll have theta to the power of minus 2. Minus 2 minus 2 minus 2 is minus 2n. So then here we have y1 multiplied by y2 multiplied by y3. So y1 multiplied by y2 by y3 is going to be the product to n of I is equal to 1 of yi. Then for this factor exponential, if you look at it, we all have 1 over theta in the factors. Then we have y1 plus y2 plus y3 and so on. So they are going to be summation to n of I is equal to 1 of yi. So this is our likelihood function of theta. And they are in a complex form. We can split them by taking natural logarithm of both sides. So ln of likelihood function is going to be ln of the products here, theta to the power of minus 2n, product to n of I is equal to 1 of yi, then exponential of minus 1 over theta, summation to n of I is equal to 1 of yi. They are n plus ln of product to n of I is equal to 1 of yi plus ln of exponential of further derivatives with respect to theta of ln of likelihood of theta is equal to 0. So we are going to have minus 2n as a constant. Derivative of ln theta is just 1 over theta. This is a constant, there is no theta, so you have 0. For this one, we have minus 1 over theta initially is theta to the power of minus 1, right? So in having these derivatives, let's have it this way. This is the same thing as theta to the power of minus 1, then summation to n of I is equal to 1 of yi. So differentiate this, power will multiply the function minus 1 theta and power will reduce by 1. Then we have summation to n of I is equal to 1 of yi and is equal to 0. So simplifying this further, we'll have minus 2n over theta. Here, minus minus become plus, so we have a plus. Then minus 1 is minus 2. So we have theta to the power of minus 2, summation to n of I is equal to 1 of yi is equal to 0. So simplifying this further, we can take this to the other side of the equation. Here we will have 1 over theta square summation to n of I is equal to 1 of yi is equal to, taking this one here, we have 2n over theta. So to simplify this further, we are going to have summation to n of I is equal to 1 of yi is equal to 2n theta. Multiplying both sides by theta square, this will vanish and 1 theta will cancel the other theta. So we have 2n theta. So divide through by 2n to have our theta. So this is our estimating parameter. So however, some values are given. Let's substitute into them and see what we have. Substituting them into the estimate. So it's 1 over 2n. We'll have 1 all over 2. Our n is 5. Then we have to have the sum of this, 9.2 plus 5.6 plus 18.4 plus 12.1 plus 10.7, and everything will give us 56 all over 10. So the estimated value is 5.6.